Good morning, class. So you guys had some homework? The homework was on exercise 1.2. Right, any issues with exercise 1.2? In number 1. Any issues there? Sorry about that. Any issues with 1.1? 1.2, sorry? Number 1? Number 2? Huh? Yes, what's the issues with number 2? Sorry? E. Which page is this on? 5. Any other issues with exercise 1.2? H. Anything else? Anything else? Did I give you the third column as well to do? So no other problems. Okay. So exercise 1.2 on page 5. So we're going to change that negative exponent to positive and that one there as well. We can't take that down because of that plus there, and we can't take that up either because of that plus. Okay, you all okay with that? If you had taken that down, then you would read 1 over x into x minus 1 plus 1. That would have actually been easy. Let me just show you. I just realized that would be easier. So if you're going to take that down, it's going to be 1 over x into x minus 1 plus 1. So what we're going to do in the denominator is to multiply to get rid of the bracket. Not so. There's 1 over. So what is x times x to the negative 1? 1. Not x. 1. Why? Because when we're multiplying and bases are the same, we add the powers. So it's going to be 1 minus, 1 plus minus 1, which is 0. Anything to the power 0 is 1. Not so. Not a O, it's a 0, no? So it's 1 plus. What's x times 1? X. That's actually very easy. But we don't think like it. Not so. We don't. And don't tell me you don't think at all. That's also going to be a problem. So what we do is, we're going to take and put that as 1 over x over, and that there becomes also 1 over x. Not so? So what's my LCM in the denominator? Remember this line here means to divide. Naturally that's over 1. What's my LCM in the denominator, people? X. That's over x. So this must be multiplied by 1. That's by x. Not so? So 1 times 1 is 1 plus 1 times x is x. So what do we do now? That division you must change to a multiplication. And what do we do? Tumble and times. Switch. So what does that become? 1 over x times x over 1 plus x. Now what? Cancel. The x's cancel. Let's leave you with 1 over much more steps. Okay, if you could have seen that initially, it would have worked. But it's not always going to be the case where you can actually apply. Okay. Let's look at the next one. It was H that you see we had a problem with on the same exercise, same page. So, like here, we can't take that Y with the X. You see that, people? So what we're going to do here, what can happen? That becomes 1 over Y squared, 1 over X squared. Not so. X minus Y over 1 over Y squared minus 1 over X. So what do I do now? Huh? Lowest common multiple, LCM. So LCM in the denominator is what? Remember again, that is to divide. What's your LCM in the denominator? X squared, Y squared. Do I need a bracket around this? No, why not? Because the denominator became how many terms now? 1 term. So I didn't need the bracket there. Do you want to put a bracket around it? No problem. Okay? Don't just think there's something wrong with you, but it's fine. No, it's okay. Right, so what do we do here? We multiply this by X squared. And this here by Y squared. So what's 1 times X squared? X squared minus. So what do I do now? Double n times. Change that to multiplication. And swap that around. Naturally, the first fraction and the first bracket is naturally over. And again, I put a bracket around that x minus y because it was 2 terms in your numerator. You see on top here, although it's 1 term in general, but in the numerator there was 2 terms. That is why I put this bracket here. Does it make sense, people? Right. Maxen. Yeah? Right. So let's swap around. You only swap around the fraction that follows the division. Okay? So you multiply that and you go x squared, y squared. People, what can happen to the top here? What type of factorization there? Dots, yes, difference of 2 squares. So it's x plus y, x minus y. So hang on. What can happen now? Cancel. Yes. Numerator cancels denominator. So what are we left with? X squared, y squared over x plus y. Good couple of sums on the question. Good couple of sums. Good couple of marks in the question. Okay. Probably like 5 marks or 4 marks. And for those of you who want a 90 odd percent, you're going to get this sum wrong, you're not going to get a 90% anymore. Okay. So that exercise number 2, make sure you know how to do each and every one of them. It's only if you want to do well, no? But most of us don't want to do well. No? We only want how much do you want? 30%. To keep on doing maths. No? That's all we want. We just want our mommy to tell the mommy's friends that we are maths students. We're doing maths. No? Yes?
If you didn't do the difference of equation, you lose more.
Because otherwise, if you're not going to do the difference of 2 squares, on top you're going to get x squared, y squared into x minus y over x squared minus y squared. Right? But the question says to simplify. So is 8 over 6, we're looking at 8 over 6. Which one is in a simpler form? 4 over 3 or 8 over 6? Over 3. So what must we do? We must simplify as far as possible. That's what maths is all about. Maths is all about simplifying. Remember, we're never going to change the value of anything. We are only simplifying. That is why maths is so easy. Because we only simplify. We're not making it bigger or smaller. Yes, Michael, what's your question? Yes? Your hand is still up. Your hand is still up. Your hand is not up anymore. Okay. Anybody else have any questions? You all okay? Now we're looking at operations involving powers, multiplying and dividing. Now you're a new subheading there. For now. Multiplying and dividing powers, we're multiplying and dividing. Write the basis as powers of its prime numbers. Now in grade 8, we spoke about products of its prime factors. Then you had to draw an adder. Not all of the, you guys remember? And you thought always that grade 8 was unnecessary. No? You shouldn't have ever thought that. Okay? It was preparing you for grade 9. Then grade 10 and so on. So we teach you things for a reason. Okay? Bill, that's on page 5. So there's the first question. Example 1 on page 5. You got a 9 to the exponent a plus 1 times 3 to the exponent 3a minus 4 over 27 to the exponent a plus 1 times 9 to the exponent a minus 2. So in pursuit of simplifying this, what's the first thing we need to do? We are going to write the basis into products of its. So make a note there. You start making notes this year, no? Yes. So you're going to make bullet points now. Okay. So the first step is we're going to write the basis into products of its. Right? Oh, you're writing it. Okay. Nice, nice. You write the basis as products of its prime factors. Okay. Right, so 9 can be written as what? 3 squared. Raise to the exponent, a plus 1. Now some of you are going to ask, how do you get 3 squared? Right, we take it from the ladder. 9, the biggest, smallest perfect square that goes into 9 is 3. 3 goes into 9 3 times, 3 goes into 3 once. So this can be written as 3 squared. Not so, there's 3 3s. If you're looking at 27, the largest prime number that goes into, smallest, sorry, will be 3, which is 9, 3, 3, 3, 1. So it's going to be 3 to the exponent. Not so? And 9 is there. I don't have to do it twice. Now some of you are going to say, but I don't want to be seen doing the grade 8 things. So no problem. You guys have a calculator on yourselves. Not so? Put the calculator on. Please make sure it's on. Press 9. The equal sign. And what we get? 9. Nice. Now you press shift. You see under the square root is this button that's 0 at minutes, seconds, and what you use in geography. But on top of it is Factorize. Press shift. By pressing shift, you're activating all the yellow keys on your calculator. Shift, that button there, gives you 3 squared. Okay. Also, I don't know if it's going to come out there. That's the button we're talking about. Nope, not coming out there. But you guys can see which one. No? It was 27, press 27 equals shift, it factorizes that button in. No? But by shifting, you're activating the yellow key, so it will take you. 108 can be written as what in products of its prime factors? What? 2 times 2 squared times 3 cubed. Not so? 1800 can be written as what? 2 cubed times 3 squared times 5 squared. And so on and so on and so on. You all okay with this? Huh? So 3 is already as a product of its prime factor, prime base thing, over 27 is 3 cubed raised to the a plus 1 times 9 can be written as 3 squared raised to the a minus 2. You all okay with that? Now what do we do? Right, so right there is the next bullet. Get rid of the brackets by multiplying out the exponents. Get rid of the brackets by multiplying out the exponents. If you remember the rule that we did in grade 8, the rule says we have a base raised to the higher exponent, we multiply the exponents. Not so. That's the rule we're going to apply there. We're getting rid of the brackets, we're going to multiply the exponents. So in other words, it's going to be 2 times a, 2 times 1. That's already sorted. 3 times a, 3 times 1. 2 times a, 2 times negative 2. So what do we get? 3 to the exponent, 2a plus 2 times 3 to the 3a minus 4 over 3 to the 3a plus 3 times 3 to the minus 4. Any issues there? Any problems? Any confusion? No. The third bullet would be what? We'll bring all the common bases together now. That's it. So when we multiplying and bases are the same, add the exponent. We divide and bases are the same, subtract the exponent. So that's your next bullet. We're multiplying and bases are the same, we add the exponents. We're dividing and bases are the same, we subtract the exponents. Okay. So what do we notice? All the bases are 3. Not so. So we're going to say 3 2a plus 2. Are we multiplying here? Yes, so what must we do? We will add that. Are we dividing here? Yes, so we will subtract. Not so. Verstaan julle? What do we get? Plus 3a minus 4. Remember, we're subtracting here. So 3a becomes minus 3a. Minus 3. Bring 2a up, it becomes minus 2a. Plus. You all agree with that? What do you think the next bullet would be? Add like terms, simplify. Add like terms in the exponent. And then you add the like terms. Don't be shy. You guys watching the videos online? If you have a problem with our homework, you watch the video again and make sure that you understand the example. Okay? Makes it easier. Okay, my relation? Have you changed your mind with regards to that now? You're at the top of the government anymore. Good. You're too lazy. No. Must rather say that all your time is being used on maths now. Don't never say you're lazy. Right? So we added like terms. So what is 2a plus 3a? 5a minus 3a. 2a minus 2a. Gone. No more a's in our lives. No? So what do we do now? We add the constants. 2 minus 4. Minus 2. Minus 2 minus 3. Minus 5. Minus 5 plus 4. Negative 1. You say, okay. But 3 to the negative 1 can be written as what? So what's the last? Your last ability is going to be? To simplify. So the answer is going to be the third. That's 1 over 3. Verstaan julle? Alright. People that sound like this 4 or 5 marks in it. Okay. So make sure you know how to do these So that's example 1. Let's go to example 2. Easy example 2. Ja. Ja, my machtig. On page 6 we have an example 2. Remember I told you I'm going to learn Afrikaans, no? My wife is very good in Afrikaans. Better than me. Okay, my English is just as bad. But the maths is now, different story. Right, example 2. On which page is this on? 6. Let's say says, example is page 6, example 2. Okay, so this sum we're going to do together. So you guys are going to write down the sum down first. Then you do the first step. What is the first step? Well, we wrote it down now. What was the first step? Basis is product. So now do it. Right, so writing it in products of its prime factors. 6 can be written as 2 times 3. Raise the exponent, a plus 1. 9 can be written as what? 3 squared. Raise the exponent, a minus 1. Over. 2, it remains 2a plus 1. 27. 3 cubed. Raise the power, a. Now what? Right, is that our next bullet we wrote there? Yes. Right, so multiply the exponents. Why? Because if we have a base raised to a high exponent, we multiply the exponents. Okay. I'll do that quickly. If you have a problem, you just let me know, okay? Try and sort you out. So by multiplying the exponents, what do we get? 2 to the exponent? A plus 1. Did you all get that?
Yes.
Many times the learner forgets to do the 2. And they write 2 times 3 to the A plus 1. It's a common made error, no? So don't be one of the common ones, okay? There's a 1 on the 2 and there's a 1 on the 2. Okay? So it's going to be times 3 to the exponent, A plus 1 times. Times what? 3 to the exponent 2A minus 2 over 2 to the exponent A plus 1 times 3 to the exponent 3. What's the next step we should be going to do? When the bases are the same, we multiply, we add the exponents. When we're dividing it, bases are the same, subtract the exponents. Okay. So only the exponents on the base of 2 will be brought together, those two. And then the 3's can be, the exponent with the base is 3's, be brought together. Okay, so do that quickly. Alright. So it's going to be 2 A plus 1. Remember this one is going to be brought up. We divide it, so what must we do? Subtract the exponents. Times. This one here would go 3 A plus 1 plus 2A minus 2. Why? Because I'm multiplying these two. Can you see that? I must add the exponents. Okay? And here I'm subtracting. So, divide. Divide, so I must subtract. So what do I do now? Add like terms. So it's 2. What's A minus A? 0. What's 1 minus 1? 0. So what happens? Anything to the power 0 is? 1. Do not forget to write that 0 there. Because if I don't write that 0 there, then that means to say that is 2 to the exponent 1. Not so. Times. What is A plus 2A? And 3A minus 3A? 0. Cancel. What is 1 minus 2? Negative 1. So that's going to be 3 to the exponent negative 1. As we see here, anything to the power 0 is? So what we're going to do now, simplify. 3 to the power 0 is 1. And that will be 3 to the negative 1. And what's 3 to the negative 1? Not all the answers is going to come to 1 of the 3. Yeah? It's by chance now. Okay, any confusion at this point? Nobody's confused. You all got it right, no? Right. Okay, so now we're going to look at adding and subtracting powers. Adding and subtracting powers. This is on page. Which page are we on? 6. Okay. This meeting. Page 6. Okay, adding and subtracting powers. Here we are told when adding or subtracting powers with unknown exponents, use the following method. Split the powers with unknown exponents. Factorize by taking out a common factor. So this is the method we're going to apply when we're adding and subtracting powers. Okay. Want to take that down, you may. Okay. So let's look at example 1 on page 7. Example 1 on page 7. So the question says to simplify. We got 3n, 3 to the exponent n plus, 3 to the exponent n plus 1 over 7 times 3 to the exponent n. So we made a note. So the first bullet is going to be split the powers with the unknown exponent. Okay, so that's going to be your bullet number 1. You guys wrote this down already. Okay? So that's going to be bullet number 1. Your second bullet is to factorize by taking out the common factor. So let's look here. So you got 3 to the n plus 3 to the n plus 1. So what are we going to break up here in the numerator? 3 to the n plus 1. That's what that first bullet told us. Okay? Do we need to split this up here? No. There's only one unknown. Not so. So let's break up. What do we get? It will be 3 to the n plus 3 to the n times 3 to the 1. How do I know we get that? Because 3 to the n times 3 to the 1. What do we do when we're multiplying and bases are the same? We add the exponent. So that's going to be 3 to the n plus 1. Not so. So the reverse is also true. The converse, the reverse, is also true. Okay? So if 3 to the n times 3 to the 1 is equal to 3 to the n plus 1, then 3 to the n plus 1 can be written as 3 to the n times 3 to the 1. Likewise, if I got 3 to the n times 3 to the negative 2, what is that going to be written as? 3 to the n minus 2. But 3 to the n minus 2 can also be written as 3 to the n times 3 to the minus 2. Make sense? Alright. So that is all over 7 times 3 to the n. What's the next thing we need to do? Factorize. And what is common here? 3 to the n. So let's take out 3 to the n as a common factor. What are we left with? 1 plus 3 to the 1. Remember we took out that as a common factor. We take the whole term out, we left with the 1. Take it out, we left with 3 to the 1. Okay, you all okay with that? And this is all over 7 times 3 to the n. Now what? What can cancel? 3 to the n can cancel. So what do we left with? What's 3 plus 1? 4. And 1 plus 3? 4. Yes, well done. You guys, I'm going to show you some promise here. No? It will be 4 over 7. Any confusion there, people? Okay, I can't help that the sum is so easy. Okay, we'll do another one. Can I move on? Okay, so it's on page 7. Let's take this away here. Example 2 on page 7. So this is the sum we're going to do together. So write this down first. So what's the first thing we're going to do? What's the first point? First bullet we said we're going to do? Split it up. Okay? So we're going to split the 5 to the n plus 1, the 5 to the n minus 1, and 5 to the n minus 1. All three of those we're going to split up. Not so? So do that quickly. Where's God's favor? Sorry? Never came to school. Went to the different school. Nice. Which school is going to? Online school. Nice. So we broke this up, not so. So this will give us 5 to the n times 5 to the 1 minus. Minus what? Am I moving too fast? You guys pause this first step already. Yes, okay. So it's going to give you 5 to the n times negative 1. All over 2 times 5 to the n times 5 to the negative. Now what? The common factor. Although 5 to the 1 is also a common factor on top. Okay, we can get 5 to the 1 out here. But I'm not going to take that out as a common factor. I'm just going to take out the one with the variable. Okay? So I'm going to take out the common factor of 5 to the n on top. So do that quickly. Alright, so if we take out 5 to the n as a common factor, what do we get? 5 to the n into 5 minus 5 to the negative 1. Not so. And that's all over 2 times 5 to the n times 5 to the negative 2. Yes, Michael?
So can you explain that factorize for the 5 to the n?
You see, if you add, if you have x times 5 minus x times 5 to the minus 1. What is common here? X is common. Then what are we left with? 5 minus 5 to the minus 1. Not so. But in x's place now, what do we have? 5 to the n. So this is what I'm saying now. 5 to the n there and 5 to the n there. So you take out 5 to the n as a common factor. Then I'm left with 5 minus 5 to the minus 1. Make sense? Now what? Now what can we do? Cancel 5 to the n as a common factor. So what we get now is 5 minus 5 to the minus 1 is what? 1 over 5. We just simplify it, no? Over 2 times 5 to the minus 2 is what? 1 over 25. Okay? So LCM on top is 5. So naturally that's over 1. So I'm multiplying that by 5. And give me 25. Times by 1. Minus 1 must be divided by. Naturally that's over 1. Nothing can cancel there. So it's 2 over 25. Which is simply 25 minus 1 is 24 over 5. Times 25. Remember we're tumbling and times. 25 over 2. 5 goes into 5 once, 5 going to 25. 5 times 2 going into 2 once, 2 going to 24, 12. 12 times 5 is 60 over 1, which is 60. We can check this using our calculator here. That in green we could have punched in the calculator. So that would simply be 5 to the exponent 1, which is 5. Minus 5 to the negative 1 over 2 multiplied by 5 to the negative 2. Giving answer 60. Okay. Any confusion at this point? You will understand. So that now brings us to exercise 1.3. In exercise 1.3 on page 8, I want you guys to do the first column and the third column. The first and the third column. Okay? You guys can start with it now. If you have any problems, you can come to me. And try and explain what the misunderstanding is. Okay? Otherwise, your homework is exercise 1.3, page 8, first and third column. Okay?